Hey there, fellow Delphi FMX developers. You know that incredible feeling when your cross-platform app really starts to take shape? But you also know that sinking feeling when the UI just isn't snappy. In this explainer, we're going to turn that laggy frustration into pure performance joy. We're going to dive deep and figure out exactly how to make your FMX apps as fluid and responsive as they absolutely deserve to be.
You know exactly what I mean, don't you? That tiny hesitation on a button press, the stuttering scroll in a long list, that animation that just kind of jerks its way across the screen. It's that sluggish feeling, that lento vibe. It's probably one of the biggest headaches in cross-platform development. But here's the good news. This is completely fixable. We just got to understand what's really going on under the hood.
And these symptoms, they always seem to pop up during the most basic user interactions, which is what makes them so infuriating. Sound familiar? That stutter when you're trying to flick through a long list, that annoying flicker when you resize a window, or my personal favorite, that tiny but oh so noticeable delay after a tap that makes the app feel disconnected. These are all classic signs that your main thread or your rendering engine is totally overwhelmed. And look, this isn't just about making things pretty, it's about whether your app feels professional and solid or just amateurish and buggy.
Okay, so how do we fix it? We're going to tackle this head-on with a really clear three-part strategy. First, we're going to supercharge the core rendering engine. Second, we'll master threading to make sure our app is always responsive. And finally, we'll get into the nitty-gritty of tuning specific components for that last little bit of peak performance. So, let's get into it.
So why does FMX sometimes feel slower than its older sibling, VCL? Well, to solve the problem, we first have to understand the root cause. And it's not that Pascal is slow, not at all. It all comes down to architecture. FMX's greatest strength, the fact that it's a cross-platform framework, is also the source of its performance challenges if you don't manage it right. All right, let's break down the trade-off here. VCL, the Visual Component Library, is basically a thin wrapper around the Windows API. It's incredibly fast on Windows because its controls are just lightweight native Windows handles and events are direct calls to the system. Super efficient. FMX, on the other hand, is a full-blown custom cross-platform engine. It draws everything itself using your GPU so that it looks the same everywhere. Now, this abstraction is incredibly powerful, but it means every single user input, every click, every touch has to go across this event bridge from the native OS into the FMX world, and that adds a tiny but measurable bit of overhead. FMX controls are also heavier objects with more internal stuff to manage, which is why performance can start to suffer when you have thousands of them on a single form.
Okay, let's jump into our first major solution. And trust me, this one is a total game changer. Think of your app's graphics engine as its heart. If the heart is weak and struggling, the whole body is going to feel slow. For a while, FMX had some default engines that were, well, they were fine. But now, we have something truly world-class baked right into the framework.
And that something is Skia. Now, this isn't just another graphics library. This is the highly optimized, battle-tested engine that powers the rendering in Google Chrome, the entire Android operating system, and the Flutter UI toolkit. This is a foundation that's trusted to deliver fast, beautiful, and consistent 2D graphics to billions of users every single day. Bringing Skia into Delphi gives FMX a massive advantage.
So what does this actually mean for your app? Well, this table says it all. With the default canvas, you might see tiny little rendering differences between Windows and Android. With Skia, you get pixel-perfect consistency. You get a raw performance boost of up to 50%. You get these beautifully smooth lines and shapes thanks to much better anti-aliasing. And the text rendering? Oh man, the text rendering quality is just in another league. It makes your whole app look and feel so much more premium. So how do you unlock all this power? You are gonna love this. No complex refactoring, no replacing all your components. For a huge number of apps, it really is as simple as this.
Yep, that's it. That is literally it. You just drop this one line into your project's main source file, right at the top before anything else initializes. And boom, you just told FMX to use the powerhouse Skia engine for everything. Every T-label, every T-rectangle, every single standard control is now rendered by Skia. This is, without a doubt, the highest impact change you can make for the least amount of work. Period.
And here's a pro tip, because we want the absolute best performance everywhere, right? If you're targeting iOS or macOS, you can get an even bigger boost. By setting global use metal to true right alongside that Skia flag, you're telling the engine to use Apple's modern low-level graphics API.
This totally bypasses the older, clunkier OpenGL layer and gives your app direct, high-speed access to the GPU. That means less latency and even smoother everything.
All right, so our rendering engine is now a beast. Fantastic. What's next? We have to tackle the #1 killer of application performance, a blocked main thread. This right here is the difference between an app that feels responsive and an app that feels totally broken. Okay, listen up, because this is critical. Your entire user interface, every button, every animation, every response to a touch, it all lives on one single thread. Think of it like a single-lane highway. If a big, slow truck carrying a heavy database query gets on that highway, everything behind it grinds to a halt. No other cars, meaning no other UI updates, can get through. If that thread gets busy doing anything other than handling the UI, your app will freeze. That's it. Game over.
So how do we keep that highway clear? Simple. We build an off-ramp. When a user action kicks off a heavy task, like a network call, we immediately offload it to a background thread using something like T-task. Now, that background thread does all the heavy lifting, completely separate from the UI. This leaves our main thread totally free to handle scrolling, animations, taps, keeping the UI perfectly fluid. And when the background work is finally done, we don't just jam the result back onto the main highway. No, we safely merge it back in using tthread.q. It's non-blocking. It just politely leaves a note for the main thread that says, hey, when you have a free moment, please update the UI with this information.
So let's make this really simple. You need to live by these rules. Rule 1, your main thread has one job, and one job only, the UI. Rule 2, anything heavy, reading files, making network calls, hitting a database, has to get pushed to a background thread. T-task and T-thread create anonymous thread are your best friends here. And please, whatever you do, avoid application process messages. I know it feels like a quick fix, but in FMX, it's a trap that can lead to all sorts of weird bugs and unpredictable crashes. It's a major anti-pattern. The modern, safe, and correct way is always to use background threads and update the UI with tthread.q.
Okay, awesome. We've upgraded our engine and we've freed up our main thread. Those are the huge architectural wins. Now it's time to zoom in and look at the finer details, the component-level tweaks that take an app from feeling fluid to feeling truly instantaneous.
Let's look at a powerful, real-world case study that brilliantly shows how a single component choice can have a staggering impact on performance. And we're going to talk about the standard FireMonkey T-memo component.
Imagine you need to load a 3 MB text file, say a big JSON response from a server, into a T-memo. With a standard styled FMX T-memo, this can take a shocking 12 seconds. For 12 full seconds, your app is just completely frozen. Why? Because the FMX styling engine is working overtime trying to process and lay out that huge block of text.
Now watch this. By changing just one property on that same T-memo, setting control type to platform, the same operation completes in just 400 milliseconds. That's not a typo. That's a 30 times performance improvement. What this does is it tells FMX to stop drawing the control itself and instead use the hyper-optimized native text editing control for the OS. You trade a little bit of custom styling ability for a massive, massive gain in raw speed.
And here are a few more quick wins for you. If you have a complex layout that doesn't change much, but it's inside a scrollable area, like a fancy list item with labels and images and all that, wrap it in a T-buffered layout. This basically caches a picture of the content, so FMX doesn't have to redraw hundreds of little controls every single time you scroll. Also remember that FMX object overhead we talked about? Yeah, try to avoid having thousands of controls on a single form. Simplify your layouts. And finally, be aware of global flags like global event-driven display updates. It's great for battery life on static screens, but if you have continuous animations, you might need to turn it off to get a nice, consistent frame rate.
Wow, we have covered a lot of ground, from high-level architecture all the way down to these little component tweaks. So let's wrap all this up into a simple, prioritized strategy that you can take back to your own projects and start using today.
Here it is, your 3-step roadmap to a high-performance FMX app. And please, the order here is critical. Start with number 1, always. An unresponsive UI is the absolute worst user experience. Your number 1 priority is to get everything that isn't UI related off that main thread. Once your app is responsive, then you can move to step 2. Upgrade your graphics engine with Skia and Metal. This is what will make your app not just responsive, but beautifully fluid and fast. And finally, once that solid foundation is in place, you can move to step 3 and start polishing. That's when you fine-tune, swapping controls to their platform equivalents and tweaking those global flags for that last little bit of peak performance.
So I'll leave you with this question to think about. We often treat performance as this technical thing, this nice to have. But in the mind of your user, there's no difference between a bug that crashes the app and a UI that's so slow it's unusable. A fluid, responsive interface isn't just a technical detail. It's a core feature. It's a statement about the quality and the craftsmanship of your work. So go on, make it a priority.